So the first one, empirical formula, if you want to work out the empirical formula, we have carbon, hydrogen, and oxygen. It was 48.65, it was 8.11, and it was 43.24. First, what we did, we divide by atomic masses. This we divide by 12, this we divide by 1, and this we divided by 16. Then we divided by, so 48.65 divided by 12. It was the same like, so 48.65 divided by 12. What was the answer? 4.0. Okay. So it was 4.054. This will be 8.11 and this was 2.7. Then we divide by the smallest value in the combination, which is 2.7. But write the 3 decimal places when you are finding an empirical formula. So this was 1.5, this was 3, and this was 1. So we multiply all of them by 2. So we get C3, H6, and O2. 43.24 divided by 16. Because the first step is divided by atomic mass. So when it is 43.24 divided by 16, that is giving 2.7025. So we divide all of them. The step 2 is divide by the smallest value in the combination. So smallest value in the combination is 2.705. That's why we divide all of them by this value. Then compound W has an empirical formula of CH4O with a relative molecular mass of 32. Calculate the molecular formula. So how we work out a molecular formula? Molecular formula is empirical formula multiplied by N. Empirical formula is given CH4O. And what about N? N is a molecular mass over empirical mass. So molecular mass, which is given 32, and empirical mass, carbon is 12, hydrogen is 1 into 4 plus oxygen is 16. That also makes 32. So 32 over 32 is 1. So when we have the same molecular and empirical masses, then the empirical and molecular formula will also be same. Next is carboxylic X and Y are both carboxylic acid. One is C2H4O2, another one is C4H8 and O2. Deduce the general formula. From these formulas, what should be the general formula? What could be the general formula of these carboxylic acid? From this, first one is having 2 carbon, 4 hydrogen, 2 oxygen. The second one is 4 hydrogen, 4 carbon, 8 hydrogen, and 2 oxygen. So if we generalize this, if we have n number of the carbon, we should have double hydrogen, so 2n hydrogen will be there, and there will be O2. So Cn, H2n, O2. Draw the structure of compound Y, show all the atoms and all the bonds. So compound Y is a carboxylic acid with 4 carbon atoms. Name of compound Y, because 4 carbon atoms. So what should be the name with the 4? What is the prefix used for 4? The prefix which you use for 4, that is but. But because it's a carboxylic acid, so it will be anoic acid. So it is butanoic acid. Here we have to write the name and this part, and then draw the structure of a butanoic acid. But means 4 carbon. So first we'll draw 4 carbon atoms. Carboxylic acid means it has C double bonded with O and OH. This will have 2 hydrogen atoms. This will have 2 hydrogen atoms, and this will have 3 hydrogen atoms. So this will be the structure of butanoic acid. Give the name used to describe a family of a similar compound with the same general formula and similar chemical properties So what we call when we have the similar chemical properties and they have the same functional group, that type of a group is known as the homologous series. A homologous series is a name given to a family of the compound which have the same similar chemical properties and they have the same functional group. Like example, alkane is one homologous series. All the alkane like methane, propane, butane, pentane, these all are refers to a series alkane which is one homologous. Alkene is another homologous. Alcohol is another homologous. Carboxylic acid is another homologous series. In part D, propene is unsaturated hydrocarbon. When we use the term unsaturated, it means it contains carbon-carbon double bond. The formula for propene is shown. State the color that is observed when aqueous bromine is added. This bromine is actually a test to check the presence of a double bond. So if there's a double bond in the compound, if bromine is with aqueous bromine is orange in color, but because of the double bond, it will turn colorless. As the reaction happen, so it will be from orange to colorless. The next is propene can be produced by cracking a long chain alkane. If we break down the long chain alkane, the breakdown of a long chain alkane is called cracking. We have a pentadecane which is C5, C15 and H32 and it is cracked to produce an alkane. One alkane is there and a propene with a ratio of 1:2 molar ratio. Like two molecules of a propene is produced and one molecule of alkane is there. So prop means 3 carbon. So C3. How many hydrogen should be there if it's an alkene? So the number of the hydrogen should be double because in alkene the number of hydrogens are twice as compared to carbon. So it will be C3H6. So it is giving 2 molecules of propene and 1 molecule of alkane. Which alkane will be there? Just a simple way. Look, here we have 15 carbon atoms. Out of 15, 2 multiplied by 3, 6 are used here. So how many we are left with? So out of 15, if 6 are used, so how many we are left with? 9. So C9. And for hydrogen, there are 32 hydrogens are there. Out of 32, 6 multiplied by 2, 12 are used here. So how many we are left with hydrogen? Out of 32, if 12 are used, so we are left with 20 hydrogen. So it will be C9, H20, and 2 molecules of propene, which is C3H6 twice. Is it clear? Anyone having a doubt or a question in this? Then propene can be converted into polypropene. Name the type of a polymerization. Remember, whenever you have alkene, what kind of polymerization is this? This is known as addition polymerization. So in addition polymerization, alkene convert into polymer. In a condensation polymer, 3 possibilities are there: amine with carboxylic, alcohol with carboxylic, or alcohol with alcohol. So 3 possibilities are there if it is a condensation polymer. But if it's an addition polymer, then we have only alkenes. So alkene will undergo addition polymer. Then in the question, complete the diagram to show the section of a polypropene. Look how it can be done. First, as I mentioned, propene. Prop means 3 carbon. So we'll have 3 carbon and ene is there. So there will be a double bond. So this will be 2 hydrogen. This will be 1 hydrogen and this will be 3 hydrogen. Now, whenever we want to draw polymer, first we rearrange the structure. When we rearrange, Our monomer, this is also a monomer, should appear like letter H. So this is carbon-carbon double bond, like these are the two carbons which are having a double bond. This have two hydrogen, one hydrogen up, one hydrogen down. And this will have one hydrogen up or down, and then there will be CH3. So this we rearrange the structure, but we have to draw a polymer. So how we draw a polymer? We draw the same structure. Yeah, you can move there. So first we have a monomer, we rearrange the structure, and then we have to draw a polymer. So if you want to draw a polymer, what we do, we draw the same structure but without a double bond. So in the question, like, and you can repeat the units. So in the question, they say section of the polymer is shown. So we have to complete. So this is one molecule. Then there will be another molecule of polypropene, of propene, which will link with each other. So here, if you want to draw H, H, H and CH3, this is one monomer. And then again, the another monomer will join. And as a result, they will form a polymer. So two monomers, identical monomers join and form a polymer. Is it clear? You can come closer. Here. So in this question, alkenes and carboxylic acid are both families of a similar compound with the similar chemical properties. Alkene and carboxylic acid have different reactions. State the term used for a family of a similar compound. What we call a family of similar compound? Homologous. So it will be a homologous series. State the journal formula of alkene. What is the journal formula of alkene? So you can use chat. You can annotate on the screen. So the journal formula of alkene is CnH2n. Alkane is CnH2n plus 2 and carboxylic acid CnH2n O2. And alcohol is CnH2n. Carboxylic acid is CnH2n plus and O2 is there. For alcohol, CnH2n plus 1, OH you can also write. Structure of a butene is shown. So butene, as you can see, it's an unsaturated, there is a double bond. So if we add aqueous bromine, this is the very common question they ask, the aqueous bromine, which is used to test the presence of a double bond. So if we have aqueous bromine, what is the color change? So it will be orange, and then it will be a colorless. So it will be orange to colorless. Whenever this is a fixed, so whenever aqueous bromine, if it is bromine, then it is red brown. But it is aqueous bromine, means bromine is dissolved or mixed with water, and it will be orange in color. State what is meant by the term addition reaction. How we define the term addition reaction? Yeah. So reaction in which we have many reactants and one product. So reaction which gives a one product by many reactants, we call. Write a chemical equation for a reaction between butene and a bromine. So butene, what is the formula of butene? But means 4 carbon. And because it's an alkene, so there will be how many hydrogen? 8 hydrogen. So C4H8. Bromine is a non-metal. Non-metal exists as a molecule. So bromine will be Br2. When they react, there will be addition reaction. So we will have only one product. So it will be C4H8Br2. Butene forms a polymer. Suggest the name of a polymer. The polymer is always named after the monomer. So only thing what we do, we add the term poly. Just whenever addition polymers are there, just add the term poly and write the same structure. So it will be butene. So this will be poly. Poly means many and butene. So polybutene will be the name of polymer. So in addition polymer, the monomers are used to identify or the polymer name is always having a monomer. So we can easily recognize. Next is name and draw the structure of isomer. Isomer means they will have the same molecular formula but different structure. Isomer of butene. Like this is butene. So what else we can draw? So we can draw but-1-ene. And if we want to draw but-1-ene, but means 4 carbon atoms. And between the 2 carbon atoms, there will be a double bond. This will have 2 hydrogen. This will have 1 hydrogen. This will have 2 hydrogens, and this will have 3 hydrogens. And you have, whenever you're drawing the structure, you will always show all the bonds and all the atoms which are linked. So this is a structure of but-1-ene. We can also draw, sorry. Yeah. So this will have 2 hydrogen, this will have 1 hydrogen, 2 hydrogen, and 3 hydrogen. This is a structure of but. And how you will know whether your structure is correct? Because count 1, 2, 3, 4. So C4 and hydrogen are 3, 4, 5, 6, 7, 8. So it means this is correct. We can also draw another structure. What could be the another structure? Isomer of alkene. What could be the other isomer of alkene? No, instead of making a branch, what else can be done? You can draw a cyclic alkane. Because a cyclic alkane, so if I draw cyclic butane, the cyclic butane will also be an isomer. So I can draw 4 carbon atoms in a structure. Switching the place, it's the same thing because but-2-ene and but-1-ene are the only 2 possible structure in terms of changing position of double bond. The other isomer of alkene, what we can draw cyclic alkanes. So cyclic butane, or also known as a cyclobutane, is actually an isomer of but-2-ene. Why it's an isomer? Because if I count, it will have 4 carbon and it will have 8 hydrogen. So whenever you're drawing an isomer of alkenes, what are the ways? You can change the position of double bond. 3 ways are there. Either change the position of a double bond, the carbon-carbon double bond. You can draw a cyclic alkane, or you make the branched. So these are the 3 ways by which you can draw the isomer. The first way we use commonly, we change the position of a double bond. The second one you can use also in the third. But third one, if you try to name, sometime it might be difficult to name. That's why I prefer that first thing, whatever you do is change the position of a double bond. But only 2 possible isomers are there. One is but-1-ene and one is but-2-ene in terms of changing a position. There is no but-3-ene. What is a branch? What we do, like example, we have 3 carbon in a structure and we make 1 carbon. Branch is a carbon chain which is attached anywhere other than the first and the last carbon. That is a branch. So if we draw the branch as well, this will have 2 hydrogens. This will have 3 hydrogen. This is already 4 are occupied, and this will also have 3 hydrogen. So this is a branched alkene. But I prefer, instead of drawing the branch, first change the position of a double bond. In this case, but-1-ene and but-2-ene, or draw the cyclic. Is it clear, this one? Then that was a name, so all the atoms and all the bonds were there. This is actually related to the previous part. Name the isomer and showing. In part D, we have butanoic acid, which is a carboxylic acid. Deduce the empirical formula. How to deduce the empirical formula? First count 1, 2, 3, 4 carbon. So C4, how many hydrogen? 3, 5, 7, and 8. And how many oxygen? O2. What is the empirical formula? Take a simplest ratio between 4, 8, and 2. So what is the simplest ratio between 4, 8, and 2? I'll divide all of them by 2. So C2, H4, and O. So we divide by 2. Then complete the equation for butanoic acid with sodium carbonate. Whenever any acid react with a carbonate or a metal carbonate, yeah, H is 8 because we count the total 3 plus 2, 5 plus 2, 7 and 1, 8. So C2, C4, H8 was there. The total number of the hydrogen. Then acid react with a carbonate, it will give salt, it will give water, and it will give carbon dioxide. So water is H2O, carbon dioxide is CO2, but which salt it will produce? Whenever organic acid is reacting with a metal carbonate, so the metal will take position of hydrogen. If it is a group 1 metal, then we write as it is. But if it's a group 2 metal, then we write a bracket and 2. If group 3, we write bracket and 3. So here sodium will take position of a hydrogen. So we'll have CH3, CH2, CH2, COO, and then sodium will take position. And the equation will balance at the last. So this will be a sodium butanoate, the salt. The water is H2O and the carbon dioxide is CO2. Then balance the equation. So if we put 2 here, the equation will be balanced. If butanoic acid react with methanol, alcohol with acid, what will the product? The product will be ester. So what is the name of ester? The first name of ester, the first part is, the ester is YL and NO8. So the first name is ester is from alcohol. So which alcohol is there? So because of methanol, so it will be methyl. And butanoic acid, so it will be butanoate. So first name of ester is always from alcohol and the second name is from the carboxylic acid. And we have to draw the structure of methyl butanoate. That is the ester which is formed. So here the ester which is formed was methyl butanoate. How to draw the structure of ester? First, you will draw C double bonded with O. Oxygen can be on the right hand side or on the left hand side. Meth means 1 carbon. So the part which is attached with oxygen we name first. So meth means 1 carbon. So it will have 1 carbon. But means 4 carbon, including this 1, 2, 3, 4. This will have 3 hydrogen. This will have 2 hydrogens. This will have 2 hydrogens. And this will have 3 hydrogens. So this is the structure of methyl butanoate. Is it clear? Any question or doubt till this point?